Assalamualaikum and hi everyone, glad to see you again. Today we are going to learn the last subtopic under electrochemistry, that is electrolytic cell. These are the learning outcomes for this topic. Electrolytic cell is an electrochemical cell that uses electrical energy to drive a chemical energy through a non-spontaneous reaction. Electrolytic cell is made up of two electrodes connected to a battery and immersed in an electrolyte. The electrode connected to the negative terminal of an external source of energy, that is battery, is called cathode, and the one with connect to the positive terminal is called the anode. Electrodes react as circuit connectors and as site for the precipitation of insoluble products. For example, like platinum, graphite, or carbon that react as inert electrode. Electrolyte is a liquid that conducts electricity due to the presence of positive and negative ions. Electrolyte must be in molten state or in aqueous solution so that the ions can move freely. For example, like molten KCl, aqueous HCl, and aqueous ethanoic. In electrolytic cell, oxidation takes place at the anode, where the negative ions are attracted to the anode, where they undergo oxidation by giving up electrons. Electrons flow from the anode to the cathode in the external wire. Reduction takes place at the cathode, where the positive ion attracted to the cathode, where they receive electron and undergoes reduction. Ions are said to be discharged, where they receive an electron or give up the electron at the electrode to form atoms or molecules. Comparison between electrolytic cell and galvanic cell. In electrolytic cell, the anode is positive terminal, whereas cathode is negative terminal. However, in galvanic cell, anode is negative terminal and cathode is positive terminal. In electrolytic cell, a battery is used in order for the non-spontaneous reaction to occur, whereas galvanic cell involves a spontaneous reaction. Factors that influencing on the selective discharge of a species at electrode. The first factor is SRP of the species. At cathode, the species being discharged or reduced is the species most easily reduced or more positive SRP. Whereas at anode, the species being discharged or oxidized is the species most easily oxidized or more negative SRP. Second factor is concentration of the species. The ion concentration influences the discharge of an ion only. An anion with a high concentration will be discharged. Factor number 3 is nature of electrode. Metal electrode or active electrode are used together with an electrolyte containing the ions of the same metal. At anode, metal anode dissolve to form ions, whereas at cathode, ions in the solution will be reduced and deposited at the cathode. If inert electrode is used, selective discharge of ion is based on the SRP value. At cathode, ion with more positive SRP being discharged or reduced, whereas at anode, ion with more negative SRP being discharged or oxidized. Active electrode is an electrode that can be oxidized or reduced in half fraction. For example, at the anode, copper solid undergoes oxidation and produce copper 2 plus ion and release 2 electrons. Whereas at the cathode, copper 2 plus ion undergoes reduction by gaining 2 electrons and produce copper solid. This is the overall equation. For the observation at the anode, copper electrode become thinner, whereas at the cathode, copper metal is deposited. Inert electrode does not participate in the chemical reaction, but serves as a source of electrons. Let us consider for the following electrolytic cell, where aqueous copper sulfate is an electrolyte and carbon electrode is the anode and the cathode. Anode is positive terminal, therefore an ion will be attracted to the anode. However, sulfur from the sulfate ion cannot be oxidized because its oxidation number is at the highest state, that is positive 6. Therefore, water is chosen to be discharged at the anode. At the anode, water undergoes oxidation and produces oxygen gas, 4H plus ion and 4 electron. Cathode is negative terminal. Therefore, cation will be attracted to the cathode. Copper 2 plus ion is selected to be discharged at the cathode. At the cathode, copper 2 plus ion undergoes reduction by gaining 2 electrons and produce copper solid. Since the number of electrons at both half cell is unequal, therefore, half equation at the cathode we have to time by 2. And this is the equation. Okay, next we can cancel out the number of electrons and we can get this overall equation. We can see bubble of gas released at the anode and copper metal is deposited at the cathode. Electrolysis of molten NaCl use liquid NaCl as an electrolyte, platinum electrode as the anode, and carbon electrode as the cathode. There are two species present in the molten NaCl, that is liquid chloride ion and liquid sodium ion. Since anode is positive terminal, so therefore liquid chloride ion is selected to be discharged at the anode. Cathode is negative terminal, therefore liquid sodium ion is selected to be discharged at the cathode. We can see a bubble of gas released at the anode and sodium metal is deposited at the cathode. These are the half equation reaction at cathode and at the anode. Since there are 2 electrons released at the anode, therefore the whole half equation at the cathode we have to time by 2. Next, we can cancel out the number of electrons at both sides and therefore we will get this overall equation. In electrolysis of water, liquid water is used as an electrolyte and carbon electrodes are used as an anode and the cathode. However, only one species present, that is liquid water. Therefore, liquid water is being discharged at the anode and the cathode. We can see that bubble of gas released at anode and also at the cathode. These are the half cell equation at the anode and half cell equation at the cathode. At the anode, water undergoes oxidation and produce oxygen gas, 4H plus ion and release 4 electron. At the cathode, water undergoes reduction by gaining 2 electron and release hydrogen gas and 2 mole of OH minus ion. Since the number of electrons in both half equation is unequal, therefore half equation at the cathode we have to time by 2 and produce this equation. Okay, next we can cancel out the number of electrons. We can combine 4H plus ion and 4OH minus ion to form 4H2O. Next, we can cancel out 4H2O at both sides. And finally, we will get this overall equation. Electrolysis dilute aqueous NaCl use aqueous NaCl as an electrolyte and platinum electrode as the anode and the cathode. Since anode is positive terminal, therefore there are 2 species present at the anode, that is liquid water and aqueous chloride ion. Because cathode is negative terminal, there are 2 species present at the cathode, that is liquid water and aqueous sodium ion. At the anode, liquid water is selected to be discharged at the anode because E naught of H2O is more negative. At the cathode, liquid water is also selected to be discharged at the cathode because E naught of water is more positive. We can see bubble of gas released at anode and at the cathode. This is the half equation at the anode and at the cathode. At the anode, water undergoes oxidation and release oxygen gas, 4H plus ion and 4 electron. At the cathode, water undergoes reduction by gaining 2 electron and release hydrogen gas and 2 OH minus ion. Since the number of electrons at both sides of equation is unequal, therefore the half equation at the cathode we have to time by 2. Next, we can cancel out the number of electrons at both sides. We can combine 4H plus ion with 4OH minus ion to produce 4H2O. Okay, the next step, we can cancel out the number of water at both sides. And finally, we will get this overall equation. Electrolysis of concentrated aqueous NaCl use aqueous NaCl as an electrolyte and platinum electrode as the anode and the cathode. Since anode is positive terminal, there are two species present at the anode, that is aqueous chloride ion and liquid water. Because cathode is negative terminal, there are two species present, that is liquid water and aqueous sodium ion. At the anode, aqueous chloride ion is selected to be discharged at the anode because of high concentration of chloride ion. At the cathode, liquid water is selected to be discharged at the cathode because E0 of H2O is more positive. We can see yellowish gas bubble is released at the anode. And we can see gas bubble is released at the cathode. This is the half equation at the anode and at the cathode. Since the number of electrons at both sides of half equation are equal, so we can cancel out the number of electrons. Therefore, we get this overall equation. Electrolysis of aqueous sodium sulfate use aqueous sodium sulfate as an electrolyte and platinum electrode as an anode and the cathode. Since anode is positive terminal, there are two species present at the anode, that is aqueous sulfate ion and liquid water. Because cathode is negative terminal, there are two species present at the cathode, that is liquid water and aqueous sodium ion. Okay, at the anode, liquid water is selected to be discharged at the anode because sulfate ion cannot be oxidized because oxidation number of sulfate is at the highest state, that is positive 6. At the cathode, liquid water is selected to be discharged at the cathode because E0 of water is more positive. We can see gas bubble is released at the anode and at the cathode. This is the half equation at anode and at the cathode. At the anode, water undergoes oxidation and release oxygen gas, 4H plus ion and 4 electron. At the cathode, water undergoes reduction by gaining 2 electrons and release hydrogen gas and 2 OH. Since the number of electrons at both sides of equation are unequal, therefore the half equation at the cathode we have to time by 2 and we will get this equation. Next, we can cancel out the number of electrons at both sides. Combine 4H plus ion with 4 OH minus to produce 4H2O. Next, cancel out 4H2O both sides of the equation. And finally, we'll get this overall equation. Faraday's law of electrolysis describes the relationship between the amount of electricity passed through an electrolytic cell and the amount of substance produced at the electrode. Faraday's first law states that the quantity of substance formed at an electrode is directly proportional to the quantity of electric charge supplied. From the Faraday first law, we will get this relationship, that is, mass of substance discharged is directly proportional to the Q, that is electric charge in coulomb. For the next calculation, we are going to use this formula where Q is equals to IT. Q is electric charge in coulomb, I is stand for current in ampere, and T is time in second. Okay, Faraday constant is the charge of 1 mole of electron, where 1 mole of electron is equivalent to 1 Faraday, that is equivalent to 96500 coulomb. Let us consider for the following example. Right, so in the question is already given the current, okay, which refer to I, 0.15 ampere, and the time, 5 hours. So therefore, your first step, you have to calculate the value of Q. We know that electric charge Q is equal to current I time T, that refer to time. Okay, next step, you can substitute all the values. Please remember, time we have to convert into second. And therefore, we get the electric charge Q is equal to 2700 coulomb. We know that 1 mole of electron is equivalent to 1 Faraday, that is equivalent to 9500 coulomb. Next, you can calculate the number of electrons passed through. Okay, where 2700 divided by 96500 coulomb, and therefore we get 0.028 mole. Okay, so because copper is deposited at the cathode, so copper 2 plus ion gain 2 electron and produce copper solid. From the equation, 2 mole of electron is equivalent to 1 mole of copper. From the previous calculation, we have 0.028 mole of electron. So therefore, it equals to 0.014 mole of copper. Next, you can calculate the mass of copper deposited more time with molar mass of copper. And therefore, the mass of copper deposited is 0.889 gram. We have reached at the end of topic 3. That's all for today. Thank you and Assalamualaikum. Bye.